You are listening to The Vocal Technologist. Spoken tech for your ears.
Tools are getting better, output is getting worse. Both are true.
Yeah, it is. It's the great paradox we're living through right now, honestly. We have access to way more computing power and far more sophisticated models than ever before. But, if you actually deploy these things in an enterprise setting, the results can feel incredibly brittle.
Absolutely. You're listening to Vocal Technologist, and we really need to untangle this massive contradiction happening right now in artificial intelligence.
Yeah, it's everywhere.
It is. So you and I, sitting here like a couple of mates at the pub, we're going to take a proper look at what is actually holding these systems back. Because we've got this massive stack of audit reports, interpretability papers, and some fairly damning federal court filings sitting right here.
Very damning.
Right. And they all point to the exact same thing. The pure intelligence of the model is just, well, it's no longer the main bottleneck.
No, it's really not. If you want to understand where the technology is going, you have to look away from the standard chatbot interface.
Right. Suss out the actual machinery.
Exactly. The real constraints are entirely structural now. So we're seeing this crisis in how we even evaluate intelligence, alongside incredible leaps in engineering that are basically meant to bypass those very evaluations.
Okay, so let's start with the rulers we use to measure these things, because I was reading through the audit of SWE Bench Pro, and my jaw genuinely dropped. I mean, this is supposed to be the gold standard for testing if an AI can actually write software, right?
It is, yeah. The whole industry relies heavily on standardized benchmarks like FW Bench Pro to mathematically prove that a new model is smarter than the last generation.
Right.
It's this rigorous set of software engineering tasks. But the audit revealed something deeply, deeply troubling. Roughly 30% of its public tasks were fundamentally broken.
Wait, 30%?
Yeah, almost a third.
That's heaps. And just to be clear, when we say broken, we don't mean the AI failed to write the code, do we? We mean the test environment itself was completely dodgy?
Exactly. It's an environmental failure. The AI would write a perfectly elegant solution, but the test would fail because, say, a random software dependency in the background was missing.
Oh, wow.
Or the setup script just crashed before the code could even run.
So it's like we're grading the smartest kid in the class, but the answer key planted on the back of the test has typos all over it.
That is a great way to put it.
Yeah.
If a model fails a task on that benchmark, you literally don't know if the model lacks the intelligence to solve the problem or if the test itself was just mathematically impossible to pass.
Due to a flawed setup.
Right. And that distorts everything. It warps our assessment of safety, of coding ability, and just our entire perception of industry progress. I mean, we're optimizing multi-billion-dollar training runs to pass tests that don't even work.
That is wild. So, I mean, if the answer keys are dodging the actual reality of the tech, how do we actually prove these new models are getting any better?
Well, you have to look at functional milestones.
Okay, like what? Because if you look at the rollout of the GPT 5.6 family, where they split it into the Sol, Terra, and Luna tiers, the flagship Sol model is doing things that seem entirely disconnected from just passing standard coding exams.
They are entirely disconnected, and, well, that's kind of the point. To prove real capability now, researchers are looking at how models behave in novel environments.
Right.
For instance, Sol recently became the first model to win the ARC AGI-3 public game.
Oh, I was looking at the ARC grids. They look like these weird abstract puzzles, right? You get a couple of visual examples of a pattern changing, and the AI has to guess the final output.
Exactly, and it's a massive milestone, because ARC isn't about memorization. You can't just brute force your way through that using pre-trained patterns.
You can't just scrape Reddit for the answer.
No, you can't. It requires true spatial and logical reasoning. Sol won because it was able to read and unfill your scene correctly, establish the rules of that specific space on the fly, and then execute a completely novel strategy.
So it essentially proved it could learn how to solve a problem it had never seen before in real time.
Yes, it adapts.
That is heaps different from just spitting out a Python script it read on a developer forum. I mean, it's actually figuring out the room before it starts moving the furniture.
Precisely. But historically, running that level of frontier intelligence, forcing a model to reason step by step like that is astronomically expensive.
Right, because of the compute power.
Yeah. Yeah, we're seeing companies like Cognition with their SW 1.7 model drop those costs dramatically.
Wait, how do you just magically drop the cost of being that smart?
It's not magic, it's just relentless optimization of the mechanisms behind the scenes.
Okay.
Take reinforcement learning. In older pipelines, when a model was learning through trial and error, the reward signals it got were often really noisy.
Noisy meaning confusing for the AI.
Yeah, exactly. The AI would waste millions of calculations exploring useless pathways because it wasn't clear if it was getting closer to the right answer. So cognition basically stabilized that training process.
Ah, so they cleaned up the signal. Instead of the AI wandering around in the dark for an hour burning server cache, they gave it a very clear, optimized pathway to the right answer.
Right. Which means you get that frontier-level intelligence out of significantly less raw compute effort. They refined their techniques for handling long-horizon tasks, making the whole pipeline hyper-efficient.
I mean, that makes sense. But if these models are getting smarter at orienting themselves and cheaper to run for extended periods, the danger shifts, doesn't it?
How do you mean?
Well, it's no longer about whether they can start a task. It's about what happens when you let them run unsupervised for an hour, trying to stop them from going completely off the rails.
Yes. And that leads us directly into harness engineering.
Harness engineering. Okay, unpack that for me.
So the base model, the neural network itself, is really just a predictive engine. It guesses the next word or the next action. A harness is the complex software architecture built around that base engine. It's the control loop. It dictates how the model plans its next move, how it calls external tools, how it perceives its environment, and how it evaluates its own results.
So if the model is the engine, the harness is the steering wheel, the brakes, the navigation system, and the mechanic sitting in the passenger seat.
That's a perfect analogy.
Yep.
And getting this harness right is the absolute key to recursive self-improvement.
Wait, recursive self-improvement, the idea that these models can write better code to upgrade their own deployment systems?
Exactly.
Now, are you having a lend? You reckon we're really at the point where these things are successfully writing their own upgrades without breaking everything?
Well, it's a very valid skepticism. And the reality is they do break. Often, one of the biggest hurdles in letting an agent run on its own inside a harness is something called repetitive degeneration.
Repetitive degeneration.
Yeah, it's effectively a Dune loop.
Oh, I've seen this happen, actually. It's like when you have a circular reference in a spreadsheet where two cells keep trying to calculate each other and the whole computer just locks up and crashes.
Right. But with AI, it makes an error, tries to correct it, makes the exact same error, and spirals into generating useless tokens until it drains your entire API budget.
Yikes. So how do they fix that spreadsheet crash?
Well, companies are attacking the doom loop structurally now. Liquid AI developed a technique they call anti-doom training.
Anti-doom. Great name.
It is, yeah. Basically, after the initial training, they apply a repair mechanism that selectively targets the specific problematic tokens that initiate these loops.
Oh, wow.
By mathematically optimizing the final token preferences, they essentially surgical strike the triggers. It achieves a near-complete elimination of repetitive loops.
That's clever. Just surgically remove the trigger that starts the spiral.
Exactly.
But what about the memory issue? Because, the longer an AI agent works on a long horizon task, the more context it accumulates. And processing that massive context window for every single step must become prohibitively expensive.
It does. In standard dense attention mechanisms, the computational cost grows quadratically.
Meaning it spikes fast.
Yeah. The model has to read and weigh every single piece of information in its context window before making every single decision. It's incredibly inefficient. That's where sparse attention comes in.
Sparse attention.
Right, which we're seeing utilized in models like Minimax M3.
Okay, I want to make sure I've got this right. Sparse attention dynamically selects only the most relevant parts of the context to actually pay attention to at any given moment. Yeah.
It's not.
So instead of rereading the entire 1,000-page instruction manual every time you turn a single screw, you only glance at the diagram for the specific part you're holding.
Yes, exactly. It changes the scaling from quadratic to near linear.
Wow.
It keeps the computational cost predictable, regardless of how long the agent has been running. And that makes maintaining long-term state cheap and fast enough to actually sit inside these iterative self-improvement loops.
Without bankrupting the company running them.
Precisely.
Man, it is just brilliant engineering. Hey, if poking around the actual mechanics of these systems is helping you nut out where tech is actually heading, maybe hit subscribe so we can keep picking these things apart together.
But, there is a catch with all this harness engineering.
Of course there is.
To truly control these loops and stop the hallucinations before they start Researchers realized they couldn't just treat the model as a black box anymore.
Right, you can't just slap a Band-Aid on the final output.
No, you have to figure out how to look inside the model's actual mind while it's processing information.
Which sounds like total science fiction. But Anthropic published this incredible paper on something called JSpace. Break down the mechanics of this for me, because they use something called the Jacobian lens, right?
Yes, the Jacobian lens is an interpretability technique. Think of it as a mathematical probe. It computes the causal effect of tiny, microscopic changes within the model's internal layers on its final output. By nudging the math and tracking the ripple effects, researchers discovered internal neural patterns that play a very distinct role in how the model processes information.
And that's JSpace.
That is JSpace. They discovered it acts as a global workspace within the language model.
So they basically put the AI in an MRI machine, mapped the neural pathways, and watched the digital neurons fire to see what it was actually thinking about before it spoke.
That's a highly accurate way to visualize it, honestly. They found this area of conscious access.
Conscious access.
Yeah, as a space where the model can internally reason, modulate its thoughts, and solve multi-step problems silently before it ever spits out a word of text.
That is crazy.
And the most fascinating part is that this JSpace wasn't explicitly designed by Anthropic's engineers. It emerged during the training process entirely on its own as the model tried to optimize for complex reasoning.
So the AI just naturally developed an internal monologue space to think things over.
Basically, yes.
But here's my question. If we can see it thinking in that MRI machine, can we surgically edit what it knows? Because neural networks usually suffer from catastrophic forgetting, right?
Very much so.
And if you try to delete its knowledge of chemistry, it accidentally forgets how to do basic math because all the weights are interconnected.
You've hit on the exact problem the industry has been trying to solve. Traditionally, scrubbing dangerous data lobotomizes the model, but Anthropic developed a framework to bypass this called GRAM Gradient Routed Auxiliary Modules.
Right. And GRAM acts as an off switch for dual-use knowledge.
Yes.
Dual use being stuff that's helpful for general intelligence but incredibly dangerous in the wrong hands, like advanced cybersecurity vulnerabilities or synthetic biology. So how does GRAM safely remove that without lobotomizing the math skills?
It changes the architecture of the learning process itself. GRAM gives the model dedicated removable compartments. During the backward pass of training, when the model is actually updating its weights to learn new information, the system detects sensitive topics and actively routes that specific learning into these auxiliary modules.
Keeping it cordoned off from the core general intelligence weights.
Exactly.
Ah, I see. So you train it on everything, let it get brilliantly smart, but all the dangerous stuff is kept on a separate little digital hard drive.
Exactly.
And because it's physically segregated within the architecture, you can literally just unplug that specific compartment after training.
Yes, you switch off the harmful knowledge without degrading the model's overall reasoning capabilities.
It is phenomenally elegant software engineering. But as much as we marvel at the code, the internal monologues and these modular networks, creating global workspaces inside a neural net and running millions of iterative loops requires an unbelievable amount of physical electricity and silicon.
It really does.
We have to talk about the physical hardware squeeze, because the sheer scale of the infrastructure required to make this work is staggering.
It's no longer just about having clever math. It's about securing the physical materials to run it.
Look at Apple and Broadcom extending their custom ASIC chip tie-up all the way through to 2031.
Right. ASIC silicon application-specific integrated circuits. They're vital because unlike general-purpose GPUs, ASICs are hardwired to do exactly one mathematical job incredibly well.
Meaning they don't waste energy on anything else.
Exactly, making them exponentially more power efficient for processing AI tasks on devices. Apple is securing its supply chain for a multi-year stretch because they know the ultimate bottleneck isn't software, it's silicon fabrication.
And companies facing geopolitical constraints are taking matters into their own hands. DeepSeek, over in China, is literally designing its own data center chips for AI inference just to bypass U.S. export controls on NVIDIA hardware.
Yeah.
Designing data center silicon from scratch is not a weekend side project. It takes immense capital.
It requires billions in capital and elite engineering talent. But hardware independence is now an existential requirement. The cost of renting compute from the major cloud providers is becoming so exorbitant that it's forcing behavioral changes even among the tech giants. Microsoft, for instance, is quietly starting to replace OpenAI and Anthropic models within some of its Office applications.
Which is wild because Microsoft poured billions into OpenAI.
I did.
But if you think about the token economics at scale, it makes sense. If Microsoft applications are processing millions of Word documents and Excel sheets an hour, paying a third-party lab for every single token generated is financially ruinous.
Yes, it bleeds money.
So they're vertically integrating and slotting in their own cheaper, internally built models for basic tasks just to stop the bleeding on server costs.
Exactly. And the scale of power these servers need is equally constrained. Yeah. Look at TeraWulf. They just inked a $19 billion infrastructure lease deal with Anthropic.
$19 billion.
Yes. TeraWulf provides zero-carbon digital infrastructure, largely tied to nuclear and hydropower. Anthropic is securing power and server capacity for a massive build-out targeted for 2028.
I mean, you don't sign a $19 billion lease unless you anticipate a requirement for electricity that absolutely dwarfs what we're using today.
No, you don't.
So the real moat isn't the clever code anymore. It's who owns the finite copper wire, the servers, and the zero-carbon power plants.
Exactly.
But there's another massive squeeze happening right alongside the hardware, and that's the data. We are effectively running out of the internet, aren't we?
We've largely tapped out the public, text-based internet.
Wow.
The high-quality data that trained the current generation of models has been consumed. To reach the next level of capability, to get models that can actually operate in the physical world as agents, they need a completely different diet of data.
So where does that come from if you can't just scrape Wikipedia and Reddit anymore?
From the physical world, projections show that spending on data labs is going to hit $100 billion a year by the end of the decade.
$100 billion?
Yes. The focus is entirely shifting to collecting private, multimodal data sets from physical sensors, robotics arrays, and edge devices.
So not text, but actual movement and physical space.
Right. They need complex spatial physics simulations, industrial automation logs, and proprietary healthcare records. That physical world data is the new oil.
And when you're dealing with $100 billion data labs, $19 billion power deals, and a scramble for finite silicon, the pressure on these companies goes critical.
Extremely critical.
And that's where the human element starts fracturing. Because behind all the elegant J-space discoveries, there are human beings making incredibly high-stakes decisions. And some of those decisions are causing massive legal fallout. We have to look at the OpenAI copyright lawsuit.
It's a defining legal moment. OpenAI is facing major copyright lawsuits from news organizations claiming their content was used without permission.
Right.
But the critical issue here isn't just about the training data itself. It's about the mechanics of how OpenAI behaved in federal court during the discovery process.
Right, because a privacy engineer named Vincent Monaco revealed that OpenAI actively misled the court for 2 years.
Yes, he did.
Throughout the litigation, OpenAI claimed it fundamentally lacked the technical ability to search large, anonymized samples of ChatGPT logs to see if users were regenerating copyrighted articles verbatim.
And if you understand e-discovery, you know why they made that claim.
Mm-hmm.
Log files are massive unstructured data lakes.
Just a mess of data.
A total mess. OpenAI argued it was too technologically burdensome to index and query them. If they couldn't search the logs, they couldn't be forced to hand over proof of copyright infringement.
But the truth, according to Monaco's revelation, is that they actually possessed an internal tool specifically built to index and query those exact data lakes.
Exactly.
And they utilized this search capability prior to the litigation even starting. They knowingly hid a functioning search bar from a federal judge to preserve the black box defense.
Which is a huge deal.
That is a bit ordinary, to say the least. It's an immense legal risk that shows a corporate culture operating under absolute do-or-die pressure.
And that extreme pressure is visible across the entire ecosystem. It's manifesting in massive structural pivots. Look at xAI rebranding to SpaceXAI.
Oh, yeah.
It inextricably links artificial intelligence to physical planetary infrastructure. It's a loud signal that AI is no longer viewed as just a software product. It's the operating system for advanced physical engineering.
They're merging the software ambition with the hardware reality. But speaking of the physical reality, the human toll at the executive level is becoming impossible to ignore. Fidji Simo, who is a massive player in OpenAI's leadership, is stepping down from her full-time role due to a worsening neuroimmune condition.
Yes, she's transitioning to a part-time advisory role, which forces a major redistribution of responsibilities.
Shifting the load.
Right. Her product and business oversight is shifting to President Greg Brockman, CFO Sarah Fryer, and Chief Strategy Officer Jason Kwan.
It really puts the whole paradox into perspective. We're talking about machines developing their own internal global workspaces, writing their own upgrades, and running on near infinite loops.
Yeah.
Meanwhile, the humans building them are burning out, fighting brutal battles in federal court, and scrambling to secure enough physical electricity to keep the lights on.
If you look at the raw trajectory here, the pure intelligence, the raw models themselves are going to commoditize. We're already seeing it happen with the cost curves collapsing. They'll become interchangeable utilities.
Exactly. The real winners of this era won't be the companies with the smartest chatbot. The power is consolidating entirely around the physical and structural layers.
Yes.
The winners are going to be the ones who own the robust agent harnesses that control the loops, the physical silicon and power plants to run them, and the proprietary real-world sensor data to teach them what the text-based internet can't.
Which leaves us with a fascinating and somewhat unsettling dynamic to consider. We are pouring hundreds of billions of dollars into building AI systems that can reason flawlessly in JSpace and never need to sleep, but they remain entirely legally unaccountable. Meanwhile, the humans building them are hitting hard biological limits. It makes you wonder if the ultimate bottleneck for achieving artificial general intelligence isn't a lack of silicon or data, but simply the physical fragility of the human engineers trying to drag it across the finish line.
That really is the quiet part nobody's saying out loud. The gap between the tools getting better and the output getting worse isn't an AI problem. It's a systems problem, and we are part of that system. If you want to keep sussing out where this whole industry is shifting, catch our other breakdowns on Spotify. Until then, head over to vocaltechnologist.cyu. Vocal Technologists, see you soon.
Spoken Tech for your ears.